Hello everybody, in today's video we're going to take a look at an example of adding a sine and a cosine curve. Okay, so the example I'm going to take a look at is 7 cos of x plus sine of x, and I want to write this as a single cos curve. So the form I'm going to write it in is r cos x, take away alpha, where r is positive and alpha is between 0 and 360 degrees. And the next part of the problem, take a look at some application. In particular, let's take a look at how to solve the equation 7 cos x plus sine x equals to some number. So I'm just going to pick number 5 here. Okay, it's the solution. So let's start with A. So we have 7 cos x plus sine x, and we know that it can be written in this form. And what we're going to use in this case is the compound angle formula for cos, which says that, let's do both, that cos plus of A plus or minus B is cos A cos B. Okay, if we go across the top, we see the plus. We need to change that to a minus. If it's a minus, we change to a plus. And then we sine it, sine it. Okay, so we're going to make use of this trig identity called the compound angle formula for cos. If we do that, we get, so cos x cos alpha. We have a minus, so we change that to a plus. Sine x sine alpha. And I want to write this in a similar form to the left hand side. So the left hand side, I can see there's a cos and a sine, and there's some numbers in front of them, 7 and 1. So I want to do that on the right hand side. So if I write cos x here, then I can see the number in front of that should be r cos of alpha. And similarly for sine, I'm going to put the sine x outside of a bracket. What sits in front of sine x? Well, this is r sine alpha. Okay, so what we're able to do now is compare both sides. So we can see there's a cos here, and the cos is already circled on the left. So this means this number here must be 7. And similarly for cos, not for cos, for sine, I mean, we have a sine here. We already have sine circled on the left, so this number must be 1. Okay, so we can build two equations. The first equation says that r cos alpha is 7, and the second is r sine alpha is 1. So for all of these problems, this process is exactly the same. At the beginning, we write it in the form that we want, which we see here, and we make the most of the compound angle formulas, which is these ones here. We expand it and compare coefficients. Okay, so let's go to a clean page and continue with the problem. So far we know the following relationship between r and alpha. We know this system, and our job is to find the values of r and alpha. So let's begin by finding R. Okay, so the trick to solving these is, well, it comes from the identity that sine squared plus a cos squared is identical to 1. And if we take our system, square each equation and add them, something quite nice happens. So let's try that. So if we square the first one, we get r squared cos squared. If we square the second one, r squared sine squared. If we add them, okay, we need to do the same on both sides. We get this equation. Now there's a factor of r squared in both terms on the left. So if I take this out, I get r squared and then cos squared plus sine squared. On the right we have 50. And we can see here inside these square brackets, this is just equal to 1. So our alphas are going to drop out of the equation, which is very helpful because then we can calculate the value of r, which is, in our case, the square root of 50. So there you go, we have our value of r. We should simplify this a little more. So inside of 50 we have 25, which is a square number. So this is 2 times the square root of 2. Okay, so this process always works. So we can always use this. Just square our equations, add them, and we can find the value of r. Next, how about finding the value of alpha? Well, the trick in this case is to divide our equations. If we divide them, well, what you can see is the values of r just cancel, leaving just a cos alpha and a sine alpha, and because we're dividing, that's just going to turn into a tan. Okay, so let's try that. So we have r sine alpha equals 1. So if we divide both sides and cancel off the r's, we find that tan of alpha is 1/7, and from this we can find the value of alpha, which is just the inverse tan of 1/7. We should be in degree mode here, and if we pop that into the calculator, you get approximately 8.1 degrees. Okay, so that completes part A. So we now know that 7 cos x plus sine of x is the same as 5 root 2 times cos x of x take away 8.1 degrees. Okay, so there you go, that's part A. For these questions, not a lot changes really. We had a 7 and a 1 here. These numbers can change. The process doesn't change too much. This always works. Okay, so let's move on to the second part of the question, a little bit of problem solving. Let's take a look at that. So part B says we need to solve, what was it, 7 cos alpha plus, cos x. 7 cos x plus sine x equal to, was it 5? Yeah, it was 5. And x was between 0, 360. Okay, I'm not going to worry about that too much. Just going to solve this problem in general. Well, from part A, we can see the left-hand side is now 5 root 2 cos of x minus 8.1 degrees equals 5. Notice how much more convenient this is, because we've calculated the sum of this cos and sine graph as a single cos graph. Things become much easier. So isolating the cos, we have 5 divided by 5 root 2, cancel off those 5's. We have a cos graph which should be equal to 1 divided by root 2. Okay, so let's take a look at solving this problem. What should we do next? Absolutely, we need a sketch. I think I'm just going to draw it from 0 to 360 degrees. This is approximately a cos graph. Okay, so let's label it up. So we know it starts from 1 when the x value is 0. One complete cycle is 360 degrees. That means 180 is in the middle. So that must be -1. Half of 180 is 90. You can see that crosses the x-axis there. And halfway between 180 and 360 is 270. And this should be equal to 1 divided by root 2. So this can be 1 over root 2 here. So where are our solutions? We have 1 here, this value, and 1 here, this value. Okay, so firstly, from my exact values, I know cos is equal to 1 over root 2 for a certain angle. The angle is 45 degrees. So this one is 45, using my exact values. So the scale is not terrible, but it's certainly not great. So I know the distance in here is 45. If that distance is 45, then using the symmetry of the graph, this one must be 45. So at this point in here, 270 plus 45, which is 350 degrees. 315 degrees, yeah. Okay, so finally, we don't have cos x, we have a slight shift. We need to take off 8.1. It's not affecting the numbers too much. We have x take away 8.1 degrees is either 45 degrees or 315 degrees. So finally, first two answers that we come across, so add 8.1 to both sides, 53.1 degrees, and let's add those up, 323.1 degrees. So there you go, we have our solutions. And more importantly, it's not just about the solution, we have the process. We can follow this process for very similar numbers. Thanks for listening.